It is time to put it all together and see what we have going on. To solve a triangle is to use the tools that we have to find the measures of all three sides and the measures of all three angles. So here's an example of a solved triangle because all the side lengths are given and all the angle measures are given. Now, to do this, you may need to use Pythagorean theorem, the fact that all the angles in a triangle add up to 180, the law of sines, the law of cosines. You have all these tools to help you get these triangles solved. So what's easiest? Typically, if you start with a set of opposites, meaning a side and angle across from each other, then I would use the law of sines. It's a little easier to use than the law of cosines. If you don't have a set of opposites, then you don't have a choice, and law of cosines needs to be where you start. A final note, we're going to use unrounded values when we do our calculations. Because if you round, you're introducing a little error, and if you then use that number to find other numbers, that error gets propagated, which isn't what we want. So we're going to do our rounding only for final answers. Okay, a couple of examples, actually a trio of examples. Here we go. When you're given a triangle, there are 6 pieces of information, 3 angles, and 3 sides. You're going to start by being given 3 pieces of information, because if you have fewer than 3 pieces of information, I put that in the wrong spot, then you just don't have enough to get things done. So angle A is 55 degrees, angle B is 104 degrees, and side A is 16 meters, right? Because that'll be across from angle A, so side B and side C. Let's not work too hard. The easiest thing to find is going to be angle C, because all the angles in a triangle add up to 180, right? So do a little subtraction of the 104 and the 55. We know that angle C is a 21-degree angle. Nice. With that in mind, I'm going to go ahead and label it, actually. Next thing to check is, okay, so I did the easy one, and there's not always an easy one. This time there was. Do we have a set of opposites? Yes, we do. I've got angle A and side A. We can then use the law of sines to find side B and side C. So let's get that set up. The sine of 55 degrees over side length A, 16 meters, is equal to the sine of 104 degrees over side length B. Cross multiply. And then divide. So my side length B is 16 sine 104 degrees over sine 55 degrees. So this is the exact value, but it's also not helpful because I don't really have any idea how big this is. So let's type that into our calculators. I'm going to switch between using the Desmos and the handheld calculator just so we get familiar with using both. So 16 times the sine of, and I've already forgotten, 104 degrees divided by the sine of 55 degrees. Do make sure that you close off the parentheses on your sine and cosine functions. Otherwise, your calculator might get a little confused. Okay, so we end up with, now this is going to be a final answer. So it's appropriate to round it here. And let's go to the nearest tenth. So this would be 19.0. And there's my side B. Side B is about 19.0 meters. Now, when it comes to using our measures here to determine side C, now we have choices. You could use this pair of opposites to set up a new law of sines, or this pair of opposites. The top one is better. And the top one is better because these numbers aren't rounded. These are the exact numbers we had to start with. If I use the rounded 19, that's going to be a problem. So let's set up a new one. We're still going to start with sine of A over A equals sine of C over C. Cross multiply and solve. We're going to have C equals 16 sine 21 degrees over sine 55 degrees. Now I want to show you a little trick. Me being a fairly lazy mathematician, I don't want to type this whole thing again. So if you press second enter, it's going to bring back everything you just typed in on the previous line. And you can just go back and change the 104 to a 21 and then delete that extra 4. Saves you a little time there. Again then, rounding to the nearest tenth, let's call this 7.0. Now, when you're finished, you should always do some checking. And what I mean is, just make sure that your answers seem reasonable, including this check. The smallest of your sides will always be across from the smallest of your angles. So my smallest side is 7, my smallest angle is 21, that matches up. The longest side will always be across from the longest angle, 19 and 104, that matches up, and then the middle across from the middle. So if those are ever out of order, it means there's an error somewhere. You should go back and find it. Okay, let's go again. This is kind of fun. So next up, let's fill in what we know. So I know angle C. I know side A. I know side B. Okay, that's it though. Do we have a set of opposites? No, we do not. Okay, we're going to have to go log cosines on this then. So the angle I have is across from the side I don't know. This needs to be the side that is over here in my law of cosines. So c squared is a squared plus b squared minus 2ab times the cosine of c. I'm once again going to go to the handheld calculator. 16 squared plus 21 squared minus sine of, and I've already forgotten my angle, 126 degrees. Okay, important to know, that's not c, that's c squared. So I want to do the square root of this number. So square root, and rather than typing the number, please use the ans, the answer. It's going to use then the whole unrounded number. So my side length c is right around 33.0. This is being measured in miles. Now, here's the thing. This is now our set of opposites. I have no choice but to use this number when I'm setting up my next law of sines. That's no problem, but don't use the unrounded number. Don't use the rounded number. Use this unrounded one. Okay, well, how do you do that then? Do you really have to type all this all the time? No, I want to show you a little shortcut. If you're on the handheld calculator, you can take this number and store it as a letter. So right now, press your store key. It's STO. It's right over here next to the 1, and it'll have an answer with then a little arrow. This is side length C, so please press your alpha key. And then if you look at there's letters above many of these keys, find the one that's got a C above it. It's the program button, and press enter. Now your calculator, when it sees the letter C, it's going to use this number. So if you press now alpha C equals, now it thinks C is this number. And it'll stay that way until you put a different number in for C. Let's see then how that's going to help us out. So in setting up our law of sines, to find, I don't know, which angle do you want to find? Let's find angle B. The sine of angle B over side B is equal to the sine of angle C over the side length. Now I'm going to call it little c here. Let's then solve for the b. So multiply the 21 over. The sine of angle B is 21 times the sine of 126 degrees divided by side length C. And then B is going to be equal to the inverse sine. Anytime you're finding an angle that is inside a sine or inside a cosine, it's this inverse trig function that gets you there. What do you type in this inverse trig function? You type all of this in the inverse trig function. So back to the calculator. I want now the inverse sine of 21 sine 126, 21 sine 126, close off the sine, divided by this c value, which I can now just press as alpha c. Close off the inverse sine, and let's see what we got. That looks to be about a 30.9 degree angle. So back up to here then, we've got angle B is about 30.9 degrees. And at this point, I would just do 180 minus these two to get that one. Again, I'd like you to use the unrounded version, so let's do 180 minus the 126 we already had, minus the answer we just got. So that means angle A is going to be right around 23.1 degrees. Quick check. Is the small angle across from the small side? Yes. Middle angle across from the middle side? Yes. Large angle across from the large side? Yes. Okay, that's an indication we've probably done things okay. All right, if you're feeling good, go ahead and delve into the practice. If you'd like one more example, here it comes. This time, what have we got? Ooh, I got all the sides this time. So side B is 14 centimeters. Side C is 26 centimeters. And side A, across from angle A, is 21 centimeters. All right. Do we have a set of opposites? We do not, because we don't have any of the angles. That means you don't have a choice. We've got to use the law of cosines. It doesn't matter which angle you find, as long as you put all the numbers in the right spots. Just to be consistent with the letters we have in our law of cosines, I'm going to solve for angle C. So let's put in what we know. That means little c squared equals a squared plus b squared minus 2ab cosine c. Okay, so 26 squared. So what do we have here? 676 equals 21 squared plus 14 squared, 637. So these I can put together. They become 637. And then this I can multiply together. 2 times 21 times 14. 588. Okay, next up, let's subtract 637. So then I have 39 equals negative 588 cosine of c. Divide the negative 588 over. And so therefore, my c is equal to the inverse cosine, because I want to get rid of that cosine. That's what the inverse cosine function is for. Negative 39 over 588. I'm going to use the Desmos this time. So on Desmos, we can do this same thing. I want inverse cosine of negative 39 over 588. 588. I'm going to just do a quick check, make sure my setting is in degrees, which it is. Now you have to reset that every time you go into your Desmos. So every time when you're doing trig stuff, sine, cosine, tangent, make sure you're set in degrees. Doesn't matter for anything else, just the trig stuff, sine, cosine, tangent. Okay, so my angle is about 93.8 degrees. So we'll come up here, make a note of that. Angle C is about 93.8 degrees. Now we don't have a choice. In order to find out another angle, I've got to use this number, but I want you to use the unrounded number. On Desmos, you can do the exact same storage trick we did on the other calculator. You can just put a C equals in front of this, And now anytime you type a capital C, Desmos knows you mean that whole big long number. Okay, let's finish this out. How about next? Let's do angle B. It's the next one up. So I'm going to be thinking here that the sine of angle B over 14 centimeters equals the sine of angle C, which, because I'm going to use the unrounded number in Desmos, I'm going to leave it written as letter C right now, over the 26 centimeters. Multiply the 14 over. So my B then is the inverse sine. That's how you get rid of that sine function. 14 sine of angle C, which is that 93.8 degrees, over 26. So I want B to be the inverse sine. And of course, I've already forgotten everything it's supposed to say. 14 sine C over 26. So 14 sine, and I'm going to type the letter C over 26. My angle B is about 32.5. Okay. So angle B is about 32.5 degrees. And then for the last angle, let's not work hard. Let's just do 180 minus these. And again, being a very lazy person, I'm just going to have Desmos store this as B, and then just do 180 minus B minus C, rather than typing everything again. I end up with about what? A 53.7? And there we go. Our triangle is solved. Now that final quick check. Big angle, big side. Yes. Middle angle, middle side. Yes. Small angle, small side. Yes. So we're probably in good shape.